Okay, example 6. It wants us to solve that cosine of 2x is equal to 1/2 for 0 is less than or equal to x less than 2 pi. Alright, so first we're going to solve this just for where cosine of 2x is equal to 1/2 in general, and then we'll be specific from 0 to 2 pi. Alright, so to find in general, we've kind of solved these equations before, but we only found where cosine of x was equal to 1/2. And remember when we did that, we found what quadrant it was in, we said our angle was equal to, and we listed our angle and we were finished. But here it's not just cosine of x or cosine of just an angle, it's a double angle. So I'm going to start out the same way though. So I need to know where cosine is. First I'm going to look and say, where is cosine positive? And we know that's going to be in quadrants 1 and 4. So I'm looking for a quadrant 1 angle as well as a quadrant 4 angle. Alright, then I want to know where in each quadrant, so I'm just going to put where is cosine, which remember is your x value, equal to 1/2. Alright, so look in quadrant 1. It's equal to 1/2 at pi over 3. But we're not just looking for theta, we're looking for 2 times x. So we're going to put that 2x is equal to pi over 3. And then in quadrant 4, we're looking for where that 2x would equal, well, cosine is equal to 1/2 in quadrant 4 at 5 pi over 3. Now, we know that because the unit circle keeps going and going and going, that this is actually going to occur every period for it. And cosine has a period of 2 pi. So I'm going to put plus 2 pi n onto both of these. So if I asked you in general, where is cosine of 2x equal to 1/2, we would almost have our answer here, okay? All we'd have left to do is solve for x and we would be done. So let's get to that point and then we're going to become more specific. So to solve for x, we got to divide by 2, and so we're going to divide everything here by 2. So that gives us x equals, remember dividing by 2 is the same as multiplying by 1/2, okay? So this gives us pi over 6 plus pi n. I'll do the same thing here. I'm going to divide everything by 2. And so we'll get x equals, dividing by 2 is the same as multiplying by 1/2, so it's 5 pi over 6 plus pi n. Now, again, like I started to say earlier there, is if I wanted in general, if it didn't say between 0 and 2 pi, we would be done. These would be our 2 answers. But it's more specific. So what we're going to do is we're going to build ourselves a table to find our answers. Alright, so in this table, I'm going to have 3 columns. My first column is going to be n. I'm going to pick some numbers for n and plug them in. My second column is going to be that pi over 6 plus pi n. And then I'm going to leave a little room there. And then my third column is going to be the next answer there, 5 pi over 6 plus pi n. And so we're just going to pick some n values. And I always start with n equals -1 because this is what I want to see in my table. In my table, I want to see that where it's too small, then I'll find where it's equal to between 0 and 2 pi, and then I'm going to find where it's too big. If it's too small, that means I don't need to go any further back, and once I get to the point that it's too big, I can stop. So I'm going to start when n is equal to -1. So I'm going to work this first one, so pi over 6 plus pi times -1, which is pi over 6 minus pi. So that's going to be what? So that's 6 pi over 6, so I got -5 pi over 6. Notice, -5 pi over 6 is not between 0 and 2 pi. It's negative. It's too small. Okay, I'm going to do the same thing for the next column. I'm going to plug in that -1. Which means I have 5 pi over 6 minus pi gives me a -pi over 6. Again, it's negative, so that's too small. We want to see that because that means, hey, we got a good starting point then. So when I go and I plug in 0 for my next one, kind of draw a little squiggle here. So I'm going to plug in 0. So pi over 6 plus pi times 0, which is pi over 6 plus 0, which is just pi over 6. That's in between 0 and 2 pi. Plug it in for the other side, so 5 pi over 6 plus pi times 0. 5 pi over 6 plus 0, which is 5 pi over 6. That's also between 0 and 2 pi. And I know those are the two answers that we found above, but there's more, okay? Multiple angles means you can have multiple answers. So we're going to keep going here. So let me extend my lines just a little bit. And I may have to go into another column here. I think I wrote too big. Alright, so let's try when n is 1. So I got pi over 6 plus pi times 1, which is pi over 6 plus pi, which is 7 pi over 6. But wait, 7 pi over 6, that's a little more than pi. It's in your unit circle. It's in quadrant 3 there, look. And so this is also going to be a solution. So I'm going to plug in 1 on the other side. So it gives me 5 pi over 6 plus pi, which is 11 pi over 6, which is also on my unit circle over there in quadrant 4. Alright, now I'm going to keep doing this until I find numbers that aren't going to work. So I'm going to have to continue my table over here into this next area. So I still got my n. I'm not going to label all these. It's just a continuation of it, okay? So then I'm going to plug in when n is 2. And so I got pi over 6 plus pi times 2, which means we got pi over 6 plus 2 pi. Well, wait, if I'm adding something to 2 pi, it's obviously going to be bigger than 2 pi, right? But let's see, 2 pi is 12 pi over 6. So when I do this, I get 13 pi over 6. That's too big. 2 pi for this problem is 12 pi over 6, okay? So therefore, 13 pi over 6 is too big. So check the other one. So 5 pi over 6 plus pi times 2. So 5 pi over 6 plus 2 pi. Again, you're adding 2 pi to something, so it should be bigger than 2 pi. And that gives us, what, 17 pi over 6? And so that as well is too big. So because it's too big, I know I have found all of my solutions. And so let's write out what our x is going to equal. So we get x equals those 4 solutions that we boxed there. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so there are our solutions for this problem. Guys, you have to check it, okay? So use that table because that'll find all of them every time.